Okay, welcome back. I guess it should be welcome back, right? Sequences and series, but welcome to the fully online. How are you feeling? Cool. So let's dive into it. We've got a few examples of sigma notation. Now, sigma notation is this exciting sign over here, right? The sigma one. And sigma means sum. So we're always looking at sum. So maybe let's just capture that and say we're always looking at the sum, plus like a series. So here we are. Example 1. Evaluate this arithmetic progression and determine the formula for Tn. Let's just run through this. We've got sigma n goes from negative 4 to 20 on 5n minus 2. So just jot that down so we can carry on together. Cool, so we're back together on this and going, now what does this even mean? Well, we've got this formula, and what we're going to do is substitute the values of negative 4 going up to 20. So negative 4, negative 3, negative 2, negative 1, 0, etc. So not just 1 to 20, but negative 4. So when we see a sigma like this, a good strategy is just sub in the first 3 values at least so we can see what it looks like. So if we put in 5 times negative 4, because that starts at negative 4, minus 2, 5 times negative 4, negative 20, minus 2, negative 22. So our first term is negative 22. And we're going to add, let's going to put in brackets even. And we're going to sub in our second term. 5 times, now we keep going up, so negative 3 minus 2 equals, well, it should be going up in 5s, right? Well, negative 3 times 5 minus 50 minus 17, yeah, so plus negative 17 plus, and we can see the pattern. I mean, we've seen this type of linear pattern before, and we know it's an arithmetic progression, so it kind of makes sense that it's going to go negative 12, but let's just put it in to confirm for ourselves. And do we get negative 12? Well, of course we do. Negative 12, plus, and so it's going to go on until the last term. Now, how are you going to work out what this last term is? Well, with a bit of luck, you thought, well, let's sub in 5 times 20, because that's our last term. We go up all the way up to 20, minus 2 equals 98. So we know that it goes up to 98. Okay, well, I don't even have to run through too much of the rest, because do you have an idea? And yes, you're going to have to jot it down. You're given an arithmetic progression. You're not told the number of terms, but you're told the first term. You've got A, you've got D, you've got the last term. So can you work out the sum of that arithmetic progression? Well, I wondered what you wrote there, because if we go, oh, well, this is easy. Sn equals n over 2, and then we've got A and L, so we might as well use the shortened version here. That's great because we've got A and L, but we don't have n. So perhaps you had said, well, Sn equals n over 2a plus n minus 1 d. But we're still going to be stuck because we don't have n. So perhaps, you said, well, that's fine because Tn equals, what does it equal again? Well, I said it equals a plus n minus 1 d, and you know the last term's 98 equals, and you subbed in the bits. But there's actually a quicker way to see how many terms there are. What is that? Maybe you're like, I don't know, come on, we haven't done this. Well, let's see, we're going from n equals negative 4 to 20. So we can use this to see how many terms there are, what the value of n is, what this nth term, what n is for this one. So let's just count it up slowly and then see how we're going to work it out. So we got negative 4, negative 3, negative 2, negative 1, 0. So that's 5 so far. And then we've got up to 20. 1, 2, 3, 4, so 20. So we've got 25 terms. So going from negative 4 to 20 gives us, not 20, 25 terms. So how are we going to figure out the number of terms just given this bottom number and this top number? Well, yeah, we're going to take this top number and subtract the bottom number. So 20 minus 4. Well, that would give us 24, but we said there are 25 terms, so we have to add 1. That's just a quick example on that. So if we were going, say, from 1 up to 5, well, we know that would be 5 terms, right? 1, 2, 3, 4, 5. So let's check it. 5 minus 1, well, that could give us 4, plus 1 gives us 5 terms. So this minus this plus another 1. Okay, cool. So from there we can go, well, S25 equals 25 over 2. A is negative 22 plus the last term, 98, into the calculator and go. Let's see. Let me plug it into the computer, into the calculator. I'm going to pause and do it. And what do we get? Equals 950. Excellent. Okay. 950. So this all looks like a whole lot of mess. Quick recap. We substituted in our first 3 so we could get the first 3 terms. We substituted in the last one, not that we really had to, but so that we could see what the last term was. We worked out n by going 20 minus 4 plus 1 gives us 25 terms, which meant we could finally go S25 equals n over 2a plus l to give us 950. Right? Cool. So let's head to the next one. So this one, evaluate this geometric progression, and goodbye calculator, and determine Tn. So the formula for Tn, but we're going to evaluate. So evaluate, sub in the first 3 values of n. So n goes from 1. So sub in n equals 1, 2, 3. And what do you get for your first 3 terms? Okay, so you merely went, cool, well, for n equals 1, 3 times a half to the 1 minus 1. Well, 1 minus 1 is 0. Anything to the 0 is 1, except maybe 0. And so 3 times 1 gave you 3. For n equals 2, 3 equals a half. N minus 1, well, I'm just going to jump straight there to 1. So 3 times a half is 3 over 2. And for n equals 3, you went 3 times a half. N minus 1, so squared. So a quarter, 3 quarters. Right, looking good so far. We've got our first ones, 3 plus 3 over 2 plus 3 over 4 plus, now how many terms are there in this series? Well, they're infinite. So we're going to keep doing this forever. So we're working out S infinity. Do you know the formula for S infinity? Well, with a bit of luck you do, right? So you're like, cool, well this is A1 minus R, isn't it? So value of A, 3. 1 minus value of R. Well, looks like we're halving each time. Kind of matches there. Look, A, R to the n minus 1. So it fitted in quite nicely. So minus a half equals 3 divided by a half gives us 6. Okay, wasn't too bad, right? That was a nice, easier one than the first one. Onwards, upwards, I think we've got 2 more examples here. Example 3, pause. Okay, the pauses are there just to get a breather. Determine the value of n. Okay, so this time we're given our formula. And we got r equals 1 up to n. We get the sigma formula and we get our answer. So, strategy. Normally, what did I suggest we did for these sigma type questions? We substituted the first 3 values so we could kind of get a sense of the series. So r equals 1, so let's put it in. So a half, so let's just put 1. A half, 3 to the 1 minus 1, well that's 0. Well, that just gives you a half. For 2, we've got a half. 2 minus 1 is 1, so 3 to the 1 gives us 3. This is looking kind of similar to the one we just had, didn't it? A half, 3 squared equals... Now this one looks a bit different. What do we have the last one? Oh, we had 3 times a half. Felt similar though, didn't it? Okay, hopefully I'm forgiven on that one. Half of 3 squared, well that's 9 over 2. Or 4 and a half. Okay, so in this case, we're working out n, so you know what the question is, ideas. Okay, so ideas as in, well, we're working out a sum, so if only we had a sum formula like Sn equals, now remember it's a geometric progression, so we're going for this a 1 minus r to the n over 1 minus r. Hit that pause button if you didn't have that down. You're like, what? Right? Okay, so what we need is a, r, and n. Well, we're trying to work out n, so we can just plug in all the other bits we know. We know the sum is 1640. A, we worked out here. Here's the first term, a half. 1 minus, what's our common ratio here? Well, 3 divided by half gives us what? Errors, 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 errors. Damn those errors, damn those errors. Okay, you know what? You know I like to leave these errors in for you to catch. Here. It's annoying, hey? Okay, half times 3. Well, that's actually 3 over 2. That's why it did actually feel similar. Okay, 1 over 2, 3 over 2, 9 over 2. Okay, that feels a little bit better now. Our common ratio is 3. But you see, also, okay, so bear with me. I like to leave those genuine errors in because so often we can catch those errors before the end of the question. So I don't want to go, oh, let me restart the recording. These are genuine errors that are easy to make, but hey, thank goodness I caught it here because I thought 3 divided by half is not the same as 9 over 2 divided by 3. So we can catch them. I think that's quite cool. Okay, so r is actually 3. Kind of matches with that 3 over there. So 1 minus 3 to the n over 1 minus 3. Whew. Okay, so thank goodness for that, right? Okay, so let's keep going here. We've got 1 minus 3 to the n. We've got one equation, one variable. So give it a go, solve, and when you get back, you'll see I'll have paused and pulled it up on the calculator. And back we are as promised. And I'm pausing at this stage of the equation. We've rearranged, and hopefully you got 3 to the n equals 6561. I've left the bit in the calculator there to show, okay, so at this stage, we just say 3 to the n equals, and we tried some numbers, and we get 3 to the 8, so n equals 8. Okay. Again, got there, eventually. Okay, so let's head for our last example on this one. Bye-bye, calculator for now. Evaluate and express in sigma notation. Let's do that in the next video. Goodbye.